Good afternoon, everybody. My name is Petrus. Today I thought I'd do something different from the usual live stream where I'm working on Bridge and instead teach you something new, a new skill. A skill I think that's tremendously valuable, and when I found out about this tool, I actually changed my primary programming language stack when I found it because it changed the way I could interact with data. Um, I used to tune and optimize and design and build SQL databases for 10 years. I would call myself like expert level relational database administrator, and I was done. I was tired of it. I was tired of dealing with the migrations, tired of dealing with the limitations in the query language, which you'll may have heard of, called SQL or SQL. It stands for Structured Query Language. And I mean, SQL's not going away. SQL is still very popular for interacting with your data, but there are classes of queries that are impossible to write in SQL or very difficult to write. And SQL is still quite verbose, and I think it got some things wrong. So today I want to teach you a better, more powerful query language, which is called Datalog. And Datalog is, or a dialect of Datalog, is the query language you use to interact with databases like Datomic, Datascript, or Datahike, which are all tools that I have in my arsenal, and very rarely now do I use traditional relational databases. Sometimes I'll use them as the backing store for these databases, so they kind of act as a layer on top of that, but very rarely do I use something like MySQL or Postgres. So today I'm going to teach you SQL. Sorry, I'm going to teach you Datalog, and the way we're going to do that is we're going to go through a website called Learn Datalog, which is a fantastic resource that I found early on. You can go to learndatalog.org if you'd like to follow along, or just look at it afterwards. I'm basically going to go through this tutorial with you using a REPL, a Clojure REPL. Alright, so what is Datalog? Datalog is, let's make this a bit bigger. Datalog is a query language that's written in extensible data notation, which is a subset of Clojure, and it's basically a syntax for writing whitespace insensitive data structures and data literals or atoms. So a data literal would be an atomic data literal would be something like a string or a number or a symbol that can't be broken up any further. And then data structures are more complex structures. They assemble data literals in some way. And so the entire query language looks like this. There are numbers, strings which have double quotes, keywords. Keywords are, you can think of them as labels. Basically they are like a symbol that only refers to itself. And then symbols which resolve to something else, like a function or a value, which could be a string or a number or a keyword, anything like that. And then you get to your data structures, and there are only a few. Basically you have to know about vectors, lists, hash maps, and sets. There's not much more than that. That basically describes most data. And as long as these are heterogeneous, which just means they can be mixed up, right? Like you can put a string or a number or a keyword inside of any of these data structures, and as long as they can nest, right? So you can have a tree, a list of lists of lists. We could have a hash map or dictionary, as it's called in many other languages, that nest. Right? So let's dive into it. Let's get to our first query. So what we have here is we have a database filled with facts about movies. Specifically, we store, I'll show you what the schema looks like. The schema consists of, it's not very long, it's the title of the movie, which is a string, the year the movie was made in, which is a long, which is like 1987, who directed the movie, and the type of this attribute is a ref or a reference, which means it points to something else, some person. A movie sequel, if it has one. So Terminator 1 might have a sequel, which is Terminator 2. The cast of the film, And importantly, the cast has a cardinality of many, which means you can have many people in the cast of the film. We care about storing a person's name, which is a string, when someone was born, when they died, and there might be some trivia about the movie. So it looks like a lot, but really it's not that many things to know about. And we stored some data already. Don't worry about this. This is just the raw data. It's like there's a person called James Cameron. There's a person named Arnold Schwarzenegger, when they were born, and then we have a bunch of movies, and we're going to be querying this data. You can go look through the GitHub repo for Learn Datalog if you like. So if you look at the first chapter, I'm going to close this, and we go to our namespace here. We have a namespace called learndatalog.user, and for today we're going to be using the following libraries. I'm using the Datomic API. We have some schema. Actually, we don't need this right now. We already have our schema built in. And we're going to read some files. The file specifically we're going to read the schema and some data that we're going to transact. And so what I'm going to do is I'm going to create a database in memory called learndatalog. Oops. I'm going to create a database called learndatalog. And then I'm going to connect to that database. And then I'm going to load our schema and our data inside of that database. Okay, so now we are going to, let's make some space here. We're going to write our first query. And the query we're going to write is we want to find all of the movies in the database. So the way we query is we say d/q for query, and that's followed by a data structure, and that data structure represents a query. And Datalog looks like this. There is a find clause followed by a series of symbols which are bound to values in the database. In this case, we care about the title of the film. And the find clause is followed by a where clause. And so the where clause has a set of constraints. So this is where it's different from interacting with a traditional relational database, where you may be familiar writing something like select from movies, or you say select title from movies. So it's similar to that, and you might add some constraints like where the year of the film was, it was produced in 1987. It's similar to that, but in Datalog, the queries are data, not a string, which means that you can interact with them programmatically. You can change the queries at compute time, at runtime, makes them more reusable. And the way these where clauses are resolved is it's like a constraint engine that tries to solve for all possible values. And so this is an artifact of being a subset of Prolog, which is an old language. It's been around for a long time. So to query for the title of all the films in the database, we'll add our first clause, which looks like this: EAVT, or entity, attribute, value, and time. And time, or transaction, means has to do with when this fact was true. Right? So if we take the shape of this query and we say, well, we want a movie, that's the entity, right? Entity is like something that you could encapsulate, like this glass is an entity, and it might have some properties like being transparent or having a certain mass. In the same way, we've stored some facts about our database, about our data. And so the movie has an attribute called movie title, and that value has some value which we shall bind to the symbol title, and we put a question mark in front of it just as a convention to say this is an unknown value that shall be bound at runtime when the query runs. So let's run this query. And what we get out here on the right, you'll see, is we got a list. Let me just make it a little bit cleaner for you. Where is our movie now? Run. Here we go. We're gonna run this query, and we're gonna get a set of values. So these are all the films we have in our database, like Alien, First Blood, Mad Max, Predator, etc. Right? So that was easy enough. We passed in this query to the query function, and we passed in a database argument. Now the reason we have to say d/db is because a connection just represents some connection to a database that could live over there, but it doesn't tell you what data you're actually interacting with. Now in a traditional relational DB, you'll send off your query to the server, it will get run on the server against who knows what data, and it'll come back with the result. And if anybody changes that data in between two queries, you're going to get a different result. This is a bit of a problem when many people or many systems are interacting with a database that's over there. It works differently in a deconstructed database like Datalog, where you actually ask for a certain value at a certain time of the data, like a snapshot in time, and then you operate against that. So what I'm going to do now is I'm going to ask for a value like that by saying ddb, and I actually get back like a reference. In this case, the db hasn't changed, so I keep getting back the same data. And I'm going to store it in a variable called db just for convenience. And now I can query against that value, and that value represents the entire snapshot of all data in that system. And if any data was transacted since then against that database, we won't know about it until we ask for it. Right? So I can run that query. So that's the first query. Let's move on to the next one, a little bit more interesting. So what if we wanted to find all the entities, movies, and their ID specifically, that were made in the year 1987? Here's how we do that. So we're going to write a query with the find clause, and we care about the entity ID of the film, which we shall bind to !movie. We have our where clause, which will be our set of constraints that narrow down the data to satisfy our query. In this case, we want the ID of the movie, and the movie must have been produced in some year. In this case, 1987. We're going to pass in our database, and we're going to run this. So what I'm doing here is I'm basically selecting this expression, and I'm going to evaluate it against the REPL. And here's what came out. This is the IDs. These are the IDs of the films that were produced in 1987. Now, what if I wanted to know the title of the film? Well, I can add an additional symbol title that we shall bind to the title of said movie. So now you see our where clauses, we've added a second constraint. So when our query runs, it goes and looks for all the facts that have, remember the shape EAVT, entity attribute value, where the entity ID is bound to the symbol movie such that the attribute movie/year that's associated with that entity has a value of 1987. And then additionally, that set of data gets run over, and it's bound if that film has a attribute. Ooh, I actually made a mistake. Sorry. There we go. Yeah. If that entity movie has a title, that the value of the title will be bound to the symbol !title, and then we pull that out. So in a traditional SQL sense, the top part is sort of like the select clause, the where is the where part, and the from is sort of implied by being the whole database, all attributes in the DB. Right. So there is our we get back a set, which is an unordered data structure of movies, vectors with the movie ID and the title of the film. And so there are only 3 films made in that year that also have a title, and all our movies have titles stored in DB. Alright, so let's see who starred in our films. So I'm going to write a fresh query, and I want to know the name of all the people who have a name. And if we run that query, we'll see these are all the people. They can be cast, they can be directors, they could be characters in the movie, we don't know. So if we that's how you find all the people in the database. Now let's get a little bit more involved. We're going to find the movie titles of all the DBs that were made in the year 1985. So we have a movie has a year, and that year I can just put in 1985. And the movie has a title, which I call title, if you call it title, not name. And if I run this, I'll get all the 1985 movies, which is 3 of them. It's Commando, Rambo, and Mad Max Beyond Thunderdome. Right? Now, if we wanted to ask a question like, well, which year was the movie Alien directed in? I'm just going to start a new, I'm going to query for a year. I'm going to say there is a movie that has a production year that we don't know, and that movie has a title of Alien. And so now if I run this query, the query engine will try and satisfy these constraints. So it'll look through all the films, all of the entities and attributes and values in the database, and it'll try to satisfy my constraint that there is a movie which was made in some year and the title of that film is Alien. And if I run this, I'll get back the value 1979. Now you'll note I got back a set. Inside of that set there is a single tuple or vector with that value. If I just want one value, I can put a dot here. It's like a shorthand to say just give me the first and only thing, and I just get the value. Alright. So now if we wanted to answer the question, who directed RoboCop? Let's see how we answer that. Now remember, we have some attributes in the database. We have movie director, which would be some person. I'll just swap these around. There's a movie that has a director, and we'd like to query against it. So let's do that. We're going to say I want the director where the director has a name, and there is a movie that has a movie title called RoboCop, and that movie also has a director which is the same director with that name. And now if we run this query, so what I'm doing here is I'm just going to pull out the ID of that person. And you can write these clauses in any order. So you could have movie title, the first clause or the second clause, doesn't matter because they all need to match. However, the order of your clauses can have an impact on the performance of the query. We can get into that a little bit later. So let's just run this query and see what comes out. In this case, we get out an ID, which isn't very meaningful for display purposes, but that is the ID of the director of the movie RoboCop. Now, if we wanted to show the name of that person, we can add an additional clause such that the entity of this person, there should be the same entity who's the director as, you know, the person who has this name, and we'd like to pull out their name. So I'll add that to the find clause. And we see that that's Paul Verhoeven, who directed RoboCop. And if we want, we can also pull out the year in which the film was shot, so adding another constraint, and put that in our find clause, and we see that Paul Verhoeven, he shot that movie in 1987. Pretty cool. So now it gets a little bit more interesting. Like you might be saying, well, I can do all of this in SQL. Why do I need this new fancy query language? Aha, well, we're at a point now where if we want to ask a question like, find me all the directors who directed the actor Arnold Schwarzenegger in a film. How would you write that query in SQL? It gets a little bit tricky, but it's very easy to do in Datalog. So we're going to start off with a fresh clause. and we're going to be querying against our snapshot of our database we took earlier. And I want to find a bunch of directors where this director, well, they'll have a name, so let's get their name as well. And there will be a bunch of movies, and the movie will have some cast in it. In particular, the cast member here is Arnold Schwarzenegger, and they will have a name which is the following. So we're going to say, go look for some cast who have a name, well, a person actually. You can call it person, maybe a little bit easier. And that there is a movie who has this person in the cast. Right? And there is a director who directed this movie. So we can say, well, the same movie was directed by some director, and that director, one or more, will have a name. So we've written a query here that will find all the cast for a film where Arnold Schwarzenegger was a cast member. The movie has a director, or many, and the director has a name, and we're interested in the director and their name. So if we run this query, we'll see there are 4 of these people who directed a movie starring Arnold Schwarzenegger. Now look how terse this query is. Go try and write this query in SQL. Much harder. You'll need intermediate tables, but in Datalog you don't need any of that. And so you can see where this is starting to go. Like, we just write down decoratively. We don't say how the database should figure this out. Just like SQL. SQL's also declarative. But we give it a set of constraints and we tell it what we want, and it will scan over all the data in the cleverest way to satisfy these constraints. Okay, let's move on to the next chapter. So far we've hard coded the values of our, the parameters in our queries. So like Arnold Schwarzenegger or 1987. But what if we wanted to reuse this query somewhere else in our database? Well, what we could do is we could add an in clause, and an in clause tells the query engine where to look for the data and the arguments, the inputs to that query to execute it. So the default data source is represented by the $. It means just take the first argument, which is the old DB, and then we can give it an additional data source. In this case, some cast member. I'll just call it the actor name specifically. And then I can replace this hard-coded value of Arnold Schwarzenegger, and I can pass in his name as an argument. And now if I run this, I should get the same result, and I do. But I can also look for another actor. I'm just gonna look. Let's look up the name of an actor, just so I know what to query for. Oops, I forgot to pass in the DB. Look, okay, Sigourney Weaver. So if we want to find the directors, excuse me, who directed a movie starring Sigourney Weaver, I can now, without touching my query, I can reuse this query, and I can run this query with a different argument, Sigourney Weaver, and I get 2 directors, James Cameron and Ridley Scott. Now what if I wanted to actually see the title of those films? Well, very easy. I just add another constraint. I say this movie has a title, and I please want the title of the film as well. And oops, I made a mistake. There you go. So it was the 2 movies, Aliens and Alien. The director and the title of films starring Sigourney Weaver. So you're starting to see how powerful this could be. Let's find all the titles of all movies grouped by year. So you're gonna write a new query. we say we want the year and the title of our films, and we're going to add in our constraints. We're going to say there is a movie that was produced in some year, and that movie has a title. I'm going to pass in our DB, and if I run this, there's all the films we have and the year in which they were produced. Pretty neat. Okay, so now, given a list of movie titles, can we find the title and the year that movie was released? Well, we just learned about parameterized queries where we could pass in some values, some inputs to our queries. Maybe we can use that to pass in a list of movie titles that we care about and get back some data about them. So let's try to write that query. We want to find the title and the year that the movie was released. So there is some movie, it has a title, it was released in some year. But if we run this query, we'll just get back all the movies, right? Like this. We are only interested in a subset of those films. We want specifically the year and the title of some films where the film has a title like Rambo 3 and Mad Max. So we add our in clause. We say, when you run this query, go look inside the data that I'm going to give you. And also, I'm going to actually provide the title of the films that you should search over. So now, after the DB argument, I can pass in a vector or any sequence of film titles. Specifically, I'm going to pass in Mad Max and I'm going to pass in Alien. So I've made a mistake, because what I told the query I would give it, I said I would give it a title, but I ended up actually giving it a list. So if I pass in one title, it works. But if I give it, how do I give it multiple values? Well, that's easy. I just need to tell the query engine that the input argument title is a vector of many things. And notice how the shape of that input argument matches the shape of my input. So it's kind of easy to see visually if it's right or not. And now we get our two values. Alright, so now we're going to really stretch out the capabilities of our graph database. We're going to say, we're going to try and find all the movie titles where the actor and a director has worked together before. So this is a little bit more complex query. We've got to think about this. I'm going to write our query. We want the title of a movie where some actor, right, and some other director has worked together. Find all movie titles where the actor and the director has worked together. Now, what does it mean if they worked together? Well, it means that the director directed the film. Maybe they could have acted in the film too. And the actor was part of the cast of that film. So let's try and write that query. We know there's a movie that has some cast member, and that the movie has a director. Find all movies as work together. Okay, I know what they mean now. All right. So we want to find all the films where specific directors or cast work together. So we're going to have to use our parameterized queries. So here we go. So like, let's say we were building a site like IMDb, then we'd want to be able to search for all the movies that the current director and the current actor work together. So we'll pass those in as arguments, and we'll pass in their names. Right? oops, pass in DB, and we're gonna pass in Michael Bean, he's a director, and we're gonna pass in, I'm just going off of the, sorry, Michael Bean is an actor, and James Cameron's director, and we're gonna pass in their names in particular, so that this director has a name, director name, and that this cast member, this actor, has, their name should match actor name. And I think we forgot to put in our movie title clause. Let's see if that works. There we go. Great stuff. So we found the two films, Aliens and the Terminator, where these two people work together. Specifically where James Cameron is the director and Michael Bean is an actor in the film. And we've managed to do that with just 5 clauses, 2 of which are about matching the name to the entity of a person. Now, I'm going to write a query. Let's make some space here. Write a query that, given an actor name and a relation with a movie title rating, finds the movie titles and corresponding rating for which that actor was a cast member. Alright, so for those who are just tuning in, we're going through the tutorial Learn Datalog today.org. You can go look it up on the internet. It's learndatalog.org. Looks like this. This is the URL. If you'd like to follow along or do this in your own time, I'm basically just going through all of the chapters and writing the queries as I go, the same way that you would. So we're going to write a query that, given the name of an actor and a relation with a movie title rating, finds the movie titles and corresponding rating for which that actor was a cast member. So that's a little more complex. So we want to find the movie title and the rating for, given some actor's name and some rating. I'm just going to leave that out for now because I don't know any of the film's ratings. We know there are movies. The movie has a cast, some actor. That actor has a name, which we pass in, actor name. And then movie also has a movie, I wonder if is it movie title? I'm going to assume it's movie rating. We can check the schema in a second. And we're just going to query that. So basically I'm going to say, give me all of the film titles and all the ratings for all the films that have a rating. It might be quite a long result. Oops, we forgot to bind movie title. So looking at my REPL on the right here, when there's an error, it says db error unbound query variables. Query is referencing unbound variables. In this case it was title. Oh yeah, and we have to pass in the actor name. So I'm just going to pass in Michael Bean from before. Unresolved empty, oh, movie rating. Okay, so it's called something. I'm just going to check the schema real quick, because I know there's a rating in here somewhere. Okay, I guess there isn't. Okay, I understand the query now. Okay, so what they're asking for here is this thing. We're gonna give you some relations, some ratings that we got from somewhere else, like IMDb, and we're gonna query against it. So we might have a film like Aliens, and it might have a rating of 7.0. Let me just check that I'm understanding the query properly. Find all movie titles with the actor and director now. Okay, here we go. So these are the relations that they're gonna give us, and they use Mel Gibson. Okay, great. So we're going to pass in an actor name and some ratings. In this case, we're going to pass in Mel Gibson. And there's a whole bunch of film ratings, like Die Hard, Alien, etc. And we can actually destructure the film title and the rating from the ratings input. We can find all movies with a given title, and we can find all of the cast members, and we're going to make sure that the cast member's name matches Mel Gibson, and we want to pull out the title and the rating. Let's see if this works. Why is it complaining? Oh, there we go. Okay, my destructuring input is wrong. I need to tell it here in the input that this consists of a title and a rating, not like this. My bad. There we go. So we've pulled out all the films starring Mel Gibson and their ratings as provided as an input to the query. Just want to check something. Okay, so that was a more complicated query, and we had to use our knowledge of the parameterized queries. We had to destructure the input. We basically tell the query engine, look, this is what this data looks like. Bind the unknown variables like this, and we had to write some clauses. Alright, so let's move on to our next chapter, chapter 4. Okay, so chapter 4, we can ask a question like, what attributes are associated with a given movie? So we're gonna write a query. We're gonna want some attributes. We're gonna provide some movie, some title. You know, I'll put in Mad Max or something, and we want all of the attributes that are associated with this movie. And so instead of specifying the attribute as we did before, we'll just leave it unbound. We'll say there is an attribute on this film, and just whatever it is, give it to me. I want all of it. And it has some value, which we don't care about, which just leave out the value. But we got to make sure that this movie does indeed have a given title, which we pass in. Okay? So I'm going to pass in the DB. I'm going to pass in the film title, which is Mad Max. And when we run this query, we expect to see a list of all of the attributes that are associated with this film. And in this case, we're just getting their IDs, because attributes are also entities in the system. But if we wanted to know the title, I guess the keyword title, like movie title, movie rating, we have to tell the query engine that, hey, there is an entity called attribute, and it has an ident, or DB ident, with a given value, which I'll call attribute name. And if I query now, I'll see, aha, we get back movie director, movie cast, movie year, movie title, movie sequel, and their corresponding entity IDs. And if we don't care about those, we can just tell it, hey, just give me a selection, a vector of all of those keywords. So now, if you're still following, you've realized that not only do we store our data inside of this database of facts, the schema, which describes the shape of that data, is also stored in the same data store. Right? That's how flexible this schema is. It can store itself. Let's move on to the next query. So now we're going to find the names of all people associated with a particular movie, including both the actors and the directors. This is a little bit more of an interesting query because we distinguish between directors and and cast. So we want the name of a person where there's a movie that has a cast. I'm not actually sure how to write this. Of all people associated with the film. I'm not sure how to write that query actually. Okay, so I had to cheat a little bit there. So what they did is they say, well, there is a movie, right? It has some attribute that is, at some cases, that has some value at sometimes, a person, and that person we know has a name. And so because attribute is unbound, it will find all of the matching entities as long as those entities have a name. Let's do an example. So we're going to find all of the people associated with the movie Mad Max, right? I'm going to pass it in as an argument. What's it complaining about? What did I do wrong? It says not a keyword. Cannot interpret as a keyword Mad Max, no leading. Why? What's wrong with that query? I don't know. Mad Max, it's expecting that Mad Max should be a keyword, but I don't see why. Right? A movie has a title, a movie has an attribute that's related to a person has a name. What's wrong with this? I'm just gonna hard code it and see if that helps. Cannot interpret as a keyword, Mad Max. Why? Why would you want to interpret that as a keyword? Okay, I don't know what's going on there. Let's go back to the. How did they do it? All right. You have to tell it. You have to tell it which attributes to refer. In this case, there are two. There's movie cast and movie director. I think this will work. There we go. All right, so it wanted to know which attributes to filter on, because I think what was happening is it was matching on some attributes that were part of the schema, and the values of those schemas are of a different type than a string, which is how we specify the movie name or the person name. And so it was trying to compare keyword values to string values, which you can't really, it's not sensible to do. They're not, they mean different things. All right. Okay, so let's move on to the next query. Find all available attributes, their type and their cardinality. This is essentially a query to find the schema of the database. To find all installed attributes, you must use the install attribute. You'll also need to use the DB value type, DB cardinality attributes, as well as ident. So a moment ago, I said that what's interesting about this database is that the shape of the database is also stored in the exact same data store. So it's sort of self-descriptive in that sense. And we don't have to query just against the data. We can also query against the shape of the database. All right, so we're going to find all the attribute. Now we want to find their names, or they actually call it the ident of the attribute. It's like a keyword like movie title, for example. And the way you find them is that there is some attr and it has a db install attribute. and the same attribute as a DB ident. I'll just call it ident. Now we're going to pass in DB. Let's just find all of the idents first. Cool, so that's everything in the DB, but that includes like internal things we don't care about. We want to find their, we'll narrow that down in a second. We want their type as well. There is a way to get the name of a type as well. I'm just going to actually pull everything about it and see if we can. I always get the order wrong. Okay, yeah, so the type also has an ident, which is just more convenient for display. Cool, so this is all the attributes in the DB with their types, but we only care about the attributes that we inserted, not the built-in types. And that's actually what the install attribute is for, because there's a specific value that signifies that this is a built-in database attribute, or this is a user land attribute that we care about. I was going to pull up the schema quickly to see what the values are. Okay, so the value to db install attribute is db part /db. I'll just hardcode that. I think this is right. That's so strange. db install attribute. Can't help but feel like I'm getting it the wrong way around. Let's try that. Okay. But that's still everything in the DB. Maybe that's what they want. I think that's what the exercise wanted. So there is a way to find only the attributes that you put in. But I've forgotten how to distinguish between them. So I'm going to cheat a little bit. I'm going to look ahead and see, well, what is it that they actually wanted? Okay, well that looks right. Yeah, this is everything. We did it. Now, something we haven't touched on yet is we're going to refer to time in the DB. We want to know when this data was transacted. And I think this is going to be the last query I do, and then I'll stop for the day. And maybe we'll do another lesson tomorrow, or we might redo this lesson if there's a new audience, just to get a little bit tighter, because this is the first time I'm doing this. So I'm going to try and answer the question, when was the seed data, this is our list of movies and actors, imported into the database? So what we'll do is we'll pull in some time, which is when, and we know that there was some movie that was inserted into the DB with some title. We don't actually mind when it happened, and it was inserted as part of a transaction. So earlier I mentioned that these where clauses have a shape. They're a for tuple with an entity, attribute, a value, and time or transaction, and we're going to use that time component now. So in this case, the transaction has an attribute called tx instant, which is the moment at which the transaction occurred from the database or the transactor's perspective, and we'll call that when. And so now if we pull out when, we see that all of this data was inserted at this same time, which was just before starting this lesson. I think this is UTC time, so that would be 20 minutes past 1, which is how long we've been going for. It's about 40 minutes. Cool. So that's the end of chapter 5. I'm just going to look at chapter 4. Let's just look at chapter 5 and see if yeah, so there's some exercises to find movies before a certain date, so they're greater than, less than. Find all the actors who are older than some other actor, and find movies that are newer than a a given year and with a rating higher than one that's provided. And if you kind of look at the answers here, you'll see that they're quite terse. You just need to know how to write them. So that's the first Datalog lesson for the day. We might do another one tomorrow. I hope this has been interesting. And if we get some feedback on this, maybe I'll formalize a little bit more. Feel free to go through this lesson yourself.